Right, good morning, guys. So today I will be doing the same, continue from yesterday, doing a Boyd simulation, but I feel like the one I have right now is terribly slow. So I'm gonna be probably, when I check out other projects, I was like briefly looking into them. I mean, I was looking into them, but I was not trying to really understand, just get some snippets of the code. But now I think I need to, Windows, what are you doing? Really try to understand what the guys are doing and then try to write it by myself. I wanted to write it with maps and then see how poorly it's gonna perform and then redo that. But it's already performing so poorly that I need to rework it straight away. Nevertheless, I want to check out these articles and then probably rewrite what I have. Probably use AI to explain me some concepts. Because like, for example, this function, I kind of understand what it does, but I want to understand why we need to use it. Right. So, what this guy was doing. Let me look at the main. Where's your main? So in the main, pretty much nothing. Boyd's new game, okay, and everything is here. So we create Boyd's. This is pretty standard. And then we have a single loop for updating all the Boyds, and I'm creating Go routine for each Boyd. And he doesn't have any maps, right? No map here. All right, and this is the big difference. Probably I will rework it, but I don't like this either, that we have a... Why should we use a single Go routine for update? Maybe due to synchronization, right? So we don't have race conditions, but I think we can improve that. All right, now... So he is centering. All right, so he's getting all the neighbors of the Boyd currently in the loop. But actually, let me start the timer so I don't lose the track of time. Alrighty. me actually add to do here. So working single game loop, get nearest voids. So he's getting neighbors. Then he calculates alignment. These are all the concepts I want to understand as well for myself. Alignment, cohesion, separation. And yeah, later on I want to detect collisions, not for now, but just to understand how it works. So alignment, how is he doing? Let me try to understand it. B, steer. What does steer do? So target is another void. We are subtracting the velocity from it, our velocity. Then we normalize and multiply. Steer force. We apply steer force. So I think I kind of get it. So we get one item, another item, and we kind of get something in the middle, and we multiply it. So we start to move. Okay, let me see what the AI will tell me. So we're steering based on average. And average is just all velocities, right, who are our neighbors, divided by count. We normalize them and multiply by speed. Multiply by alignment force. Okay. So what does normalize do? The vector. Lengths of exactly 1. This check is there because vector. Okay. Yeah, separation. Okay. Should have asked it to write some code. Northeast, gradually steer to northeast. Yeah. So so alignment is how we want to steer all the boids relative to the others. Gravity, right? Cohesion is like gravity. So we need to calculate all three, then apply different weights. Something I need to think about it as well. Think about. Distance between, yes, so I need to calculate distance between them. Alright, so if I have 3 and 4, yes, the vector is 5, okay. When you normalize, you divide each component 3 by 5, or 6 or 8. So now we get exactly 1. So we convert... Length is 1, alright. So we remove the magnitude, right, completely, and then multiply it. Yeah, so we normalize it, then we multiply it by the magnitude we want to get. So we get the averages. Okay, now it's kind of have way more clarity about that. Or 1 length of square root diagonally. Your neighbor 5 units away. Okay, let me read alignment. All right. So we take the average divided by the count, subtract our velocity. We're getting the how much we should be moving towards all the others. And then we can multiply it so we don't straight away turn, but we turn slowly. Okay, makes sense. Yeah, and cohesion is the same, but just for position. Okay. Right, let's try to write the stuff by our own, by ourselves. Alright, so we will remove map. This is music. I'm gonna use this. Let's initialize it. My gosh, hey man. problem. Boss, hey, hey, hey. How are you, my man? So I'm getting the vector. Oh, am I being stupid? I'm being stupid. Is this the right way? Maybe we should use pointers. But okay. Oh, wow. So we have insane acceleration probably. Okay. Hello, hello, good morning everyone. Abbas, Deus. And they're speeding up like crazy. I'm always happy to see how you study and work during live broadcasts. Keep it up. Thank you, man. Nice, very nice of you. And it's like a pleasure for my ears. Make separation radius 10. Okay. Okay. Something is moving. What if we make separation radius a bit bigger? I mean, we are not doing any separation right now. At least our... Okay. Let me think what we should do next. Actually check his project, how he's doing. Okay, I'm doing this a bit differently. Normalize, multiply, okay. Then steer. A lot of normalization. Let me think about what I'm doing. So I'm taking average velocity. This is the actual average velocity. We are removing our velocity. Then we normalize it. Then we give it some speed. Alignment force. Do we need this? Probably this is already not needed. It can be a single variable. Okay, let's test it out. Let's set bounce on border back. Set cohesion radius here. For now, without separation. Alright. What if we remove this part? Will infinitely speed up. Okay, they have such crazy speed. We are not even... slowing them down. Yeah, probably we need that. Yeah, let me think. distance is less than separation radius. Push in the beam position. From our position we need to subtract others' position. Just need to normalize it and multiply by separation force, something like that. That. Oh wow. Exploded on the border. You need to think about bounce on border and why they need to steer them. Okay, let's think about it. Let's make voids a bit smaller. Let's have something like wall. Invert on wall. Should I name it wall margin? Because those green widths divided by 10, something like that. So I want wall separation. Should return also vector to D, and we will add it to our acceleration, but I need to think about it. Should we do it? Yeah, I think we wall. Let's name it lab wall separation distance. Wall separation force. Let's do it for 5 as well. And then let's make it stronger for 1. So we reject from the wall. So we need as well something similar, right? To what we did here. Also separation, why am I? Wall separation. This is going to be vector to D once again. So if our beam position X is less than this wall separation distance, what should we do? We should get kind of acceleration it's gonna be wall separation distance minus the position x divided by wall separation distance, something like that. So the closer we get to the wall, the smaller this value and the higher this acceleration, and we will multiply it by wall separation force. Acceleration probably wrong. And force. Now we need to do it for all the sides. On the other side we will have width minus if we are here, right? Use it. Okay. Now we will have it the other way around, right? X minus right x. And divided by right x. Yep. Then this right. Yeah, probably it's gonna become negative, and that's what we want. Okay. Now the same for y side. Maybe I'm just doing some some bullshit. Let's see. Right, y. I just need to change the screen height, separation distance. Yeah. Right x, probably. It's diff. This is gonna be. Yeah, now we have this wall separation. We will add it as well. Do we need some kind of thinking? Need some kind of... Okay, let's try it out. Oh wow. I show shooting them from the wall. Okay. So if I touch the wall, then it's just an explosion. Okay, I think this is the mistake in here. Do we need bounce on bottom at all? I think we don't. Where is it? Let's not bounce. Let's allow. To go a bit off screen. Okay, maybe that's not a bit. Okay, I did correctly on this side, incorrectly on that side. So, alright, I'm accelerating to the bottom. Now I'm accelerating there as well. Alright, so I did something completely wrong. Here's the wall separation. Think about it. So if our position, I feel like I need to start drawing. So here we are, right? Our void is moving here, right? So his position X less than wall separation. Let's think this is wall separation, right? We are somewhere here. We're coming into here. Taking this distance. Let's say it's 10. Here it's X is 5. And divide it, right? So the closer we get, the stronger it should bounce us off. Okay, what about the other side? So here X, let's assume 100, this is 90, right? As soon as our X is greater, position X minus width difference. Should we divide by position X? Oh, we need to minus force, right? So we need to force them into opposite direction because I was speeding him up. We need to force him outside. Alright, now position Y. Once again, plus force. And here minus. Okay, let's try it. Okay, we should, bounce on borders anyway. Feel like, or we need to make this force greater. Wall separation force. Or 5. I don't know. Still, we are going outside. Okay. We keep accelerating. Yeah, we should not allow bounce outside. And we should normalize the speed, right? Because the speed isn't actually... We are increasing speed indefinitely. I think that's the problem. Acceleration. Let me think, how should this work? Let's do something like that. Normalize the limit. Yeah. Just like this. Oh yeah. Seems like... Seems like that's what I should do as well. And mean speed 0. Okay, just let's do X. Now what do we do here? If mean speed is greater than magnitude, then our D, let's name this magnitude, right? Current length, no, length is keyword, magnitude is the magnitude. Get this function right. normalized, and the current win, normalized by len. What's the problem? Oh. Multiply by min speed. I'll just return this. Now, if max speed is less than, and normalize and multiply by max speed. Otherwise we just return parent, right? We don't change anything. Something like that. Position, now Gif velocity. Min speed like this. Velocity. Yeah. Okay. Okay. Okay, now we are staying within the screen. Yeah, that was the problem. Maybe let's make this a bit smaller, even divide by 15. Let's make max speed 4, all separation force even greater. And let's make 150 voids. Let's see. So we've clammed up into one nice ball. They're not steering towards each other. Oh yeah, now they're okay. Okay, interesting. Okay, how can I get the FPS I'm having? Full FPS. Debug print. What is that? Okay, let me add this part. I wanna see the FPS. No. Where you getting screen from? Ah, it's in the draw. Yeah, makes sense. We don't have a bit on util. What is that? Ah, we can see FPS here in the corner. Okay. 60, 70, 55. So the closer they get. Okay, let's double voids. 15. Should increase separation force. Let's make it all 5. No, that's too much. Or 25. So they split up. And they already split up. So should we make cohesion force even smaller? 0.05. Which one am I using? We don't need this stuff. Speed. Already overkill. kind of clamped up. Moving is a weird thingy. Okay. What if I will make separation force 1 or even 2? Will they split up? Now they're still being pulled together, but now they're just in this weird... Okay, let's make it 5. Ah, that's wall separation. Yeah. 5 here. Okay, I need to think how to separate them properly. Okay, at least we have 57, 52 FPS. Okay, now it's 40. I think we already have way too many elements. Starting to look like something. But still definitely not the void simulation. Okay. And they are sticking together. So separation. Yeah, probably separation should depend. Let me check how he's calculating separation. Should depend on how close I'm getting. The closer I get, the stronger should be bounds. Cohesion separation. Divide by diff lengths. Yeah. Probably that's the way to go. Yes, and I have count cohesion, and I should have count separation. So we'll start probably separating all this. see. Alright, now they're just all over the place. Okay. Now let's reduce separation force by 1 to 1. Alright. Okay, now it's kinda okay. Some are separated, but I think we can live with that. Obviously there are improvements and we are sticking to, we are not dropping below 50 FPS. But I'm curious, what if we will make 600 here? Okay, now we are at 15 FPS. Yeah, now it's a problem. Oh, shish. Now problem. Yeah. Alright, so this is the good opportunity to find optimizations. Let's make it 400. 400 is gonna be okay. Yeah, 30 FPS at 400. Some of them came from the other side. How? Made. Alright. Definitely something is happening. Yeah, actually I'm not doing the rejection completely. Should I add it? Should I not? Right, I will take a quick break. I need to think what's next. Should we add actual fish? Because I prepared some assets. Like a background. I don't know if we can add a GIF to this. And I have already fish. Fish number 2, fish number 3. And the sprite of fish. So you can try to replace the balls with the actual fishes. I have no idea how to do that. Probably I'm just gonna ask AI, but nevertheless, or we can add wall bounds. Okay, I'm gonna go on a quick break. All right. Alright, so there is a problem with border. Okay, let me try to wipe code my way into adding fish into the screen. To invert the wall. Maybe let's add this part. Because I've seen that some voids are outside of the screen. Still somehow some of them are outside. Okay, let me drop this baby into AI. Okay, let me actually update the timer. Half an hour. That I need to wrap it up. Yeah, about half an hour is available for me. Geom. Okay, let's write it out. So yeah, we will have more fish images. A beaten image. Is that the same? Yeah, it exists. Now I need to add init. So we'll read them from the file. Beaten util new image from file. Cool. Slash press redir. We'll probably do it like so. So if it's PNG, sprite sheet, nope. Slash assets. Error. No panic. Otherwise, dear. Okay, yeah. For range deer f if f strings what is it, f dot name, yep, as nope, strings as suffix. How do I do this? Yeah, so why aren't you suggesting me this as suffix as string png? Is there extension file dot is there info file info? What's that? Does inf returns file info? File info. What is file info? Name size is there. Okay, so the same thing. Mode. What's mode? Okay. Okay. Makes sense. Is there x? No extension. We need to also have that close. Have dot. Okay. Not sure how I can close the file, but nonetheless, if strings have dot name and strings dot contains fish. If that's the case, we need to append it. What did I name it? Fish images. Yeah. Fish images and yeah. Then we need to actually read it, right? And then we will beaten util new image from file and f dot name. The only thing, this is going to be probably fmt sprintf, and your path will be your path fmt sprintf. This is going to be string and string. What's up with the music? I reached the end of the playlist. And this is going to be your path and our name. Right. What do you return? You return image, and error, right? So I assume I'll trust AI. We don't need the image. We need just this part. If we're getting error, we'll panic because we should not get error. Otherwise, we will add image like so. We delete this part, now, how can I close the files that I was reading? I forgot how to do that. File info. Okay. Let's ask our best friend. Reads directory entities, opens the file, reads, so you need to defer f close. It's fine as is, but you only need to worry about closing if you were using lower level function that return open file like os open, which returns os alright, os read dir. But do I have f close? No. I'm feeling I had this. I mean, I had Golang had it. Alrighty. And now okay, let's make some kind of target size. Fish. Okay. Nice. Let's make it 20. What do we do? Draw. images. We just run. And in then images. Yep, it's the image. Okay. Alright, now in draw we have our image. In void draw, right? And here, let's comment this out. Maybe we'll use circle. So widths 4. Okay, that's the image bounds dx. Okay, so we can get bounds. Let's return the bounds on the image. Okay, so it's right out of the box. Amazing. dy. Now angle. Mass and okay, what is angle? It's probably which direction we are going. What is a10? And returns the arc target of xy using the c sign for the to determine the quadrant of the return value. Okay. Alright, I'll trust the evident in this case. B. Why are we doing velocity y then velocity x? Yx here, okay. Velocity I, B. Velocity x. Then draw image options. G1 color scale. Okay. Feel like this is the whole separate learning thing. But for now, we're just trusting the AI. Okay, let me copy this stuff. Yeah, maybe this part. So we move center of image to origin. We centralized it. Scale. Rotate. Okay, so it matches the velocity. Move to void's world position. Okay. Sounds exactly what we need to do. Now let's see if it's gonna work. Obviously doesn't. Passive fish PNG, not such file. Okay, and because I didn't make this slash here. Okay, we have fish. but they are not really visible. And we have surprisingly 100 FPS. Okay, let's make our fish bigger. Let's make fewer of them. Make 100. 30. Okay, they're moving backwards. They're moving, and we have fish on the screen. Okay. Let's make them even bigger. And let's rotate, I don't know, minus angle. Is it how it's supposed to work? Okay, it looks a bit weird. They're not moving into... but already something. Already something. Okay, we need to add probably separation radius will depend. Everything should depend on fish size, right? So we'll say fish target size times 2. Let's do times 1.5. The same for, well, we can do cohesion radius times 2, even bigger maybe. Separation radius, fish target size divided by 2. Something like this. Did I do something wrong? Well, I was copy and pasting, so hard to make a mistake. A10, really? This is YX, right? We're providing YX. Rotate, minus angle, scale, translate. What does translate take? dx dy. So right now, all fish are moving backwards. Tail first, and do not really. Okay. Angle plus mass pi. Okay, this is a bit of okay. Adding math pi 180 degrees to rotate angle, which splits the sprite to face the correct direction. Okay, I feel like I need to go to school again to learn math, but okay, this is pretty cool. That I need to remember all of that. Okay, are we moving head first? Yeah, now kinda head first. Okay, now our fish is turning. Okay, I don't know guys if you can see it. Let me make actually screen twice bigger. I don't know if it's gonna be a bit too much. Okay. They're moving quite slowly. Let's make 300 fishes. We have 30 FPS or current rate, 40, 50. Probably you can't see it, but it's here in the top left corner. Some fish are getting stuck. He's like, wait for me guys. Okay, my kid's gonna love this. Right, we getting something more or less realistic. Okay, some fish are getting stuck. I'll need to think about, okay, he got unstuck. And some are outside of the screen. How is this happening? I edit. We are literally switching direction. Or am I pushing them out of the screen and now they cannot? Okay. Yeah, I feel like due to separation, I'm pushing them outside of the screen. But they are returning back on the next row. Which is kind of okay, not ideal. Okay, what if we make fish size 75? It's gonna be too big. So are they upside down? Okay, I feel like I'm already happy with what I've got, and you see guys, white coding images, but okay, I'm fine with white coding this kind of stuff because I don't want to spend time reading a Beaton's documentation. That's not the point. Nevertheless, let's add the final thing. I have as well a background like this. I don't know if we can make it. Can I set Gif or Gif as a background? And have Gif's animation work. She does not natively support animated GIFs out of the box. Okay, that's sad. We'll only load the first frame of a GIF. You need to decode all frames manually yourself. Here is the approach strategy. Okay. Okay. Let's read it. We need to store decoded frames, their duration, and the current time. Okay, so we decode each frame and then we need to draw them. Load GIF, open. Okay, we are opening, decode all. So I would assume this is already available on GIF, image GIF, right out of the box. Frames, we're getting frames, delay between frames, bounce, okay. Withdraw over is important. As diffs between frames. Vision runs at 60 fps. 4 seconds of delay. That means 1 second, which is 6 ticks at 60 fps. Okay, so we need to synchronize it with the update. Okay, let me commit what we have for now. Alright, so since I'm limited on time, let's just copy paste this stuff and see if it's gonna work or not, and then I will try to figure out how it's actually working. Hit an image, BG frames. Okay. Load GIF. Okay, let's add this part. game update. Okay, let's try this part at least ourselves. G tick plus plus. Alright, so we are adding ticks. Threshold noise times 60. Alright, so this is how we are synchronizing them. Threshold less than 1, threshold is 1. Okay. Okay, I'll need to understand all of that. But for now, let's just write it down. If bg tick is 0, gbg frame divided. Okay, so we're taking frame plus 1. So we're keeping them in the loop. Okay, kinda get it. Modulo len gbg frames. Who is int? What are you? Int L no. BG frame. What is BG frame? It's integer. So why can't I modulo it? Oh. Good. Yeah, the rest is the same. And the only thing we need to... Oh, there's more. In the animation game room. Okay, at this point I'm gonna trust it. Nothing to watch. The background is and the screen is okay. Okay, let's add screen size 1080. Let's keep it the same as the image. Okay, like on init. That's int. So what are we returning? And delays. What we need to do is here. What did I break? Okay. There we go. Okay, way too many fish. Or should we scale it? Two. Now we have an aquarium. Okay. Alrighty, guys. Would play around a bit more with this stuff, but I need to go do some other stuff. What if we will resize it? How it's gonna look? What if we will make it once again 640 and yeah, let's make it 1080p. It's gonna be ugly. Is it gonna work at all? Yeah, the animation works. That's cool. I wanna figure, yeah, next stream probably I will try to understand a bit more how we synchronized GIF or GIF with our game. It's pretty cool. Alrighty. Skidzen, hi. What music playlist do you use? I feel like I need to add already something into... Are you on Twitch or are you on YouTube? Sorry, I closed all those tabs. I just have one centralized chat. Okay, I can see you're on YouTube. There we go. And Twitch, guys, if you're curious, here it is as well. Alrighty, guys, I'm gonna commit the code. Next stream I will figure out what I copy paste from AI, and then we will, I don't know, either work a bit more on the mechanics of the game. I will think about it, or we will start thinking about optimization, because yeah, if I will add 600 fish, it just starts to be like 15 FPS. edit Gif Background. Alrighty, once again, thank you everyone for watching. We'll see you next time. Take care, guys.